Hi students, last topic of piecewise functions. So topic 3, writing equations of piecewise linear functions. So we've evaluated, we've graphed, and now we're going to write those equations here. So warm up 1, this graph represents Andre's distance from his bicycle as he walks in a park. So whoever is showing this video, hopefully you pause right now. I want you guys to all try this warm up number 1 that is on this page. So again, pause the video now. Okay, I'm going to go through this warm-up. So this graph represents his distance as he walks in a park from his bicycle. So distance in feet from his bicycle and time in seconds. For which interval of time is the value of the function decreasing? So we're increasing through here. Then we're decreasing from about right here over to here. So that's from about 9 to 11. So for which intervals is he decreasing? From about 9 to 11 is decreasing. And then from about 14.5 to, we're decreasing all the way over to here. So that would be at 17. And then we're also decreasing from right about here, which is at 21. And we're decreasing all the way till over here, which is at 27. So there's our decreasing intervals. It also then asks which intervals are increasing. So we're increasing all the way from 0. Oh, maybe. Okay, from 0 to 9. So from here all the way over to that decreasing spot there. We are then increasing from here, which was at 17, up to 21. So between these ones right here, and between this one right here, that one's not increasing or decreasing. That's why we don't have it listed. So describe what Andre is doing during the time the value of the function is increasing. So as that function is increasing, so the distance in feet is going up, that just means that he's walking away from his bicycle. So that's what we know is happening then. Not only should we be able to graph piecewise functions when we are given their equations, but we should be able to translate the graphs of these functions into equations. So here's our example 1. The function f of x is shown graph below. Write a piecewise linear formula for the function. Be sure to specify both the formulas and the domain intervals which they apply. So here, and it's up to you kind of how you want to do it, but we have f of x equals. For this one, we're going to have three different functions. There is a line between there. So we're going to have 3 different functions. So I'm going to start on this leftmost one. And this goes from 1, 2, 3, 4, 5, 6, 7, 8. So this is at -8 all the way to -2. And then over here, we're at 3, 4, 5, 6. So we just need to know those intervals there. So this first one is going to be from -8 is less than or equal to x, which is less than or equal to -2. The middle one then is going to be from -2 to 3. I'm going to not include on both of those. And then from 3 to 6 is where we're going to take the last one. You can choose which one to include or not include on the -2 and the 3s because they're at the same spot on this line. Okay, so writing the equations. So because I have a point, I'm just going to write this in point slope form. So I've got a point right there that's at -2, 4. And I have a slope. Let's see if we can figure out our slope here. Is it up 3 over 2, up 3 over 2, up 3? Yep, it's up 3 over 2. So the slope of this is up 3 over 2. So I have that slope of up 3 over 2, and then I have a point, so I can do x plus 2 plus 4. So I'm writing that in that transformation form again with that point that is there. So -2 and +4. In the middle here, we're at a horizontal line. So 1, 2, 3, 4. That's at 4. So that is just the number 4 between -2 and 3. And then between 3 and 6 here, I can do it based on this point. So this point is at 3, 4. And my slope here is going to be -2 over 1. So we have a slope of -2 with a point of 3, 4. So we write x minus 3 plus 4 there. Okay, so there's my equation and my interval, equation, interval, equation, interval that you use. And that's kind of how we can write that. Okay, moving on to our next example. The function f of x is shown graph below. Write a piecewise formula for the function. Be sure to specify both the formula and the domain intervals for which they apply. So we'll do this one slightly differently. I'm going to do each piece individually. So I'm going to look at this very first one. I'm working left to right. So this one is, the line here is at 2. So that is a horizontal line. It's just a number for an interval. And you can use whatever notation you want over here. But for an interval from negative infinity all the way over to 2, and it's inclusive of 2. So we're going to do that one. Now, if I go to the next one, if I'm looking at this, we have a slope of up 1 over 1. So the slope is 1, and we have a lot of points. I'll use this point that's right here. That's at 7, 8. So I'm going to do a 1 as a slope, and then x minus 7, and on the outside plus 8. For an interval that goes from not including 2 to 7 and including 7. So there's my interval notation there. And then lastly, we would have the line that's here. So we're starting at 7. We have a point. I'm going to use this point right here. So this point is at 8, 6. We have a slope of 1. So same slope. I'm going to do x minus 8 plus 6. 4. And for this one, we are starting at 7, but not including it. So that's the parenthesis, comma, to infinity, because we're going all the way to the right there with that arrow. Remember, these numbers are x values that are over here. Okay, on to our last example here. So the function f of x is shown graph below. Write a piecewise linear formula for the function. Be sure to make the formula and the domain intervals over which they apply. So for this one, again, we're going to just do f of x equals, and I'm going to split it up. I have 2 functions here. So for this one down here, I have a point at -1, -6. And we have a slope of up 1 over 1, so a slope of 1. So we're going to have 1, and then x plus 1 minus 6 will work for the equation. And for the interval is, for this one, is from negative infinity, again, not because it goes down, but because it goes left, all the way to -1. And it's inclusive of that because that is a filled in circle there. And then for the second part of this here, we're going to go from 4. So I'm actually going to start with that, from 4 to infinity. Again, to infinity because we're going all the way to the right. So this is the side of infinity, and this is the side of 4. And that function is just going to be a number, and it's at a y value of 4. So that function is going to produce a 4 over that range that is there. Okay, what you are going to do now is the 3 homework problems that are on here. See if you can write these functions.